Okay, good morning. Welcome to
FamilyMath419.
419. Okay, so we're going to take a look at the dice rolling problem today, into we roll until we get a duplicate. Okay? But this was a hard problem, right?
Yeah.
We didn't really have any good way to approach it yesterday. So today I want to try to think of how we could approach this problem. Okay, so for example, if I roll the dice, let's put it down here on a sort of random way. Let's see. So the number is 111, 47, 60. What is that? 86, 96, and 19. So did we get a duplicate?
No.
Okay. So how can I quantify this more mathematically instead of just rolling dice?
Well, maybe you can say like the first time you roll a die, you can like cross off the number.
Okay. So I could cross off 111.
So like 111 has happened.
Okay.
And then
you cross off the next number,
All right.
which 47 you've had.
47 we've had.
And
Okay.
you've had 60, 96, and 19.
Okay. So what is that helping me do?
It's helping you get into a smaller range of numbers.
Okay. So what's the probability of rolling the same number when I roll two dice?
well, it would be
Well, the first number can be anything.
Right.
so it would be
And the
Next
second
number
number
has-
has to be the first number.
so that's a 1 out of 120.
Okay. And what's the probability of not rolling two numbers?
119.
19 over 120.
Okay. So 1 and 120, we're going to get it in 2 times. And 119 out of 120, we won't get it. We won't get a duplicate in 2 times. Okay. What about with the third dice? What's
Well-
happening here? What's the probability of getting the first time we see a duplicate on the third roll?
Well, it would be 2 out of 120 because you can get 2 possible numbers. On this die, that would be the same.
So we have this number can be anything.
Uh-huh.
Now, since we have another die, this number can also be anything. But this number has to be either this or this.
Right.
And
But
these 2 numbers have to be different.
very good. These 2 numbers have to be different. So this number can be anything, 120 out of 120. That's
Yeah.
a different way of writing
Mhm.
one. This number has to be 119 out of 120.
Because it can't be this number.
Uh-huh.
And
And then the other one,
So I'm in this situation.
then the next one has to be one of these two.
Okay, so that would be 2 out of 120. But it's this, and then up there. And what's the probability that I roll 3 different numbers when I...
then
Roll
120
through this.
over 120 times 119 over 120, and then
118.
118.
Okay, and then I have different other combinations.
Mhm.
But does this help you see how we can look at how many rolls we're going to need until we're likely to see a duplicate?
Well, yeah.
Okay, what should I do?
Well, I would, with probability, you want to multiply.
Okay.
So, but this is still going to be pretty close to 1 that you don't.
That's true. But what is that bottom row telling us?
It's telling us what the numbers can be in our range.
No, what's the probability on the bottom telling us when I multiply all this
It's the
numbers?
probability that you
That-
have a number that you got a number that all of these numbers are different.
Okay. And why is that helpful?
Because looking at when they're the same is hard, but it's kind of a complementary counting approach.
Okay, there you go. So this problem is easier to do by complementary counting. It's easier to see what's the probability that I get no duplicates. And now that helps me understand, how do I know, if I know the probability of getting no duplicates, how do I know the probability of getting a duplicate?
You can just subtract it from the total.
Subtracting it from the total. And so how am I going to know what these numbers are on the bottom to get no duplicates?
Well, because you're picking out numbers. Like this number is anything. The only restriction on this number is that it can't be this number. And then this number can't be either of these 2. This one can't be these 3. And this one can't be any of the 4.
Okay.
So, wouldn't that be 120 times 119 times 118 times 117 times 116
Okay.
all over 120 to the fifth.
Yeah, very good. Let's go to Wolfram Alpha and take a look at that real quick, and then
Okay.
we can wrap up for this morning.
Okay.